Hello all, I hope you're all doing great. I'm Shruti Sudhir. I'm a data science and business analytics intern at the Sparks Foundation. This is my third task as part of this internship, and the third task is all about making predictions using the decision tree algorithm. So initially, I import the required libraries of pandas and numpy, and then for this case as well, I'm using the iris dataset. So I read the dataset which is in the form of CSV, and then I create the pandas data frame. As you can see, these are the first 5 rows of the data frame, wherein species is a target variable which I have to be predicting with the help of the remaining 4 columns. So we can see here that there is a ID column along with the pandas default ID or indexing column. So in order to prevent that confusion, I am removing the ID column from this data frame. So after removing the ID column, I move on to finding out the shape of this data frame. So there are 150 rows and 5 columns in this data frame. After this, I move on to finding out the data types of each column in this data frame. There are 4 continuous variables and 1 object or categorical variable. And this categorical variable is a target variable which I have to be predicting using the remaining 4 continuous predictor variables. So this is a classification problem. Next, I move on to the step of data cleaning, wherein initially I check for the existence of missing values. As you can see, there are no missing values in this data frame. And then I move on to removing the duplicate rows in this data frame. So after removing the duplicate rows, I find the shape to be of 147 rows and 5 columns, indicating that there were 3 duplicate rows in the data frame which are now removed. After this, I move on to the data analysis part to find out the distribution or any particular trend that is being followed by each of the columns in the data frame. So initially, I use the describe function to obtain the descriptive statistical summary of the continuous features available in the data frame, and I get to know certain measures of mean, standard deviation, median, etc. of the continuous features. So after this, I move on to label encoding. So as you can see, the column of species was of object data type. That means it was categorical, and machine cannot directly interpret categorical variables. So in order to overcome that problem, we use this process of label encoding. So here I have used a label encoder, which is a part of scikit-learn.preprocessing library. So I create the object and I fit and transform my species column of the data frame, and after that the label encoding is done. So as you can see, all the categorical uh, variables are converted to some sort of numbers like 0, 1 and 2. So for better understanding of the data and its distributions, I move on to data visualization. And for data visualization, I use uh, two main libraries of Seaborn and Matplotlib. So initially I find out the count plot of the species variable. So as you can see in this count plot, there are 48 rows of category 0 and 50 rows of category 1 and 49 rows of category 2. So they are almost equal in number with slight variations. And after this, I move on to find out the distributions of the remaining continuous predictor variables. So as you can see, these two are the distributions of sepal in centimeter and sepal with centimeter. Both of them are almost following a bell-shaped curve, which is similar to normal distribution. And then I move on to find out the distributions of the petal length centimeter and petal width centimeter. It is exhibiting more variations when compared to the remaining 2 continuous features. So since we cannot make out much from the univariate visualizations except for the output variable, let's move on to the multivariate analysis to find out how each feature is uh, influencing the other features, especially the output feature. So I use the heat map where the correlation is considered. So considering the last row in this, since we are concerned how the species variable is being affected by the remaining 4 continuous predictor variables, I can see that the correlation is high when for continuous variables of petal in centimeter and petal with centimeter versus the species variable. So since these two are showing high correlation, which indicates that these two have high influence on the species variable when compared to the remaining two continuous features. So let us keep this in mind while deploying the model. And then I also move on to using the pair plot to understand how it is being varied. So you can see that for these two continuous variables, there is clear distinguishing of the species category when compared to the remaining two continuous features. So after this, I move on to separating the target variable from the predictor variable. Initially, I'll consider all the 4 predictor variables for learning or for building the model. So considering all the 4, I'm dropping only the species, which is the output variable. And then I create the data frames, and then I split the data set into train and test data. So after splitting the data set, I move on to import the decision tree classifier from the scikit-learn.tree library. And then I create the decision tree classifier object, and then I fit to the training data sets. And then after training, I use that model to predict on my test data. So these are the predictions that are obtained. And on comparing, these are the actual values and these are my predicted values. And since it's multi-classification, I'm using the simple metric, evaluation metric, which is accuracy. So I can see that the accuracy obtained on the simple model deployment is 95.55%. Now, in order to visualize this decision tree, I import tree from the sklearn library, and then on visualizing, this is the decision tree that is obtained. So as you can see, there are a number of parameters that are considered at each node, something like the Gini index, samples, value, and the class. So the Gini index can be thought of as that metric or that measure which is calculated by subtracting the sum of squared probabilities of each class from 1. So using many such metrics like this, the decision tree or the decision tree algorithm at each node decides as to which class it belongs to and how the further splitting is to be done. And these hyperparameters can also be modified and as we wish in the algorithm. So that is what I'll be doing in the next step. And one more thing that I'll do is, as we have seen that the variables of petal in centimeter and petal with centimeter showed high correlation with the target variable of species, I'm considering those two to be the predictor variables, and I'm removing the remaining variables from the data frame. And after that, I again move on to splitting the data set into test and train data. And then after that, I again create a new object of decision tree classifier with a random state 0, which means only that particular kind of sample is going to be taken. And then with a max depth of 5 and min sample sleeve of 3. So max depth is nothing but which indicates the maximum depth of the tree. So when I give 5, the decision tree is only going to be expanded up to the maximum depth of 5. It is not going to go beyond that. And then I have also used another hyperparameter of min sample sleeve, for which I have assigned the value of 3, and it indicates the minimum samples of leaf required to be at the leaf node. So based on these two hyperparameters that I have given to this decision tree classifier object, the splitting would be done and the decision tree would be created. So using this, I have created a model and I'm fitting the train data into this. And after the model fitting is done, now I'm using that model to predict on my test data. and these are the predictions that I've obtained. Now, again on comparing, these are the actual values and these are the predicted values. Now I'm again using the same evaluation metric of accuracy, and you can see here my accuracy has increased a bit to 97.77. There are a lot many hyperparameters which can be tuned and as we wish to increase the accuracy or to increase the model's performance on different kinds of data. So this is the simple hyperparameter tuning that I've done. And on visualizing this decision tree, this is the decision tree that I've obtained. As you can see that the maximum depth is 5, and this is the and only petal with centimeter and petal and centimeter, since these two are the only two predictive variables that I'm considering. So this is the final decision tree that I've obtained. So I hope this is a good work done by me, and thank you to the Sparks Foundation for giving me this wonderful opportunity to work with them and for giving some interesting data science problems. And thank you all for those who have evaluated my tasks earlier. And I hope to get your valuable feedback down in the comments. Thank you.